From the previous video, we learned about the isosceles special right triangle. Now, we are going to learn about the 30 degree, 60 degree, 90 degree special right triangle. So, let us try to get the length of the sides of this special right triangle using the Pythagorean theorem. Consider triangle ABC with right angle at C. Angle A is 30 degrees and angle B is 60 degrees, where BC is equal to A, AC is equal to B, and AB is equal to C. We need to prove that the length of the hypotenuse is equal to twice the length of the shorter leg, and the length of the longer leg is equal to square root of 3 times the length of the shorter leg. When we reflect this right triangle, we combine angle DAC and angle CAB, we will get a 60 degree angle. And since angle D is a reflection of angle B, this is also 60 degrees. When all our angles are congruent, we are creating an equilateral triangle. So for equilateral triangles, all sides are congruent. Now this side, which is C, is congruent to AD, which is also C, which is also congruent to DB. Now, if DB is C, then CB is A, which is half of DB. We can say that DC and CB are both A. So, C here is the same as twice of A, proving that the length of the hypotenuse is equal to twice the length of the shorter leg. Now, let us prove that the length of the longer leg is equal to square root of 3 times the length of the shorter leg. Okay, using the Pythagorean theorem, which says B is equal to the difference of C squared and A squared, we will substitute 2A for C. Therefore, B is equal to the square root of 2A squared minus A squared. 2A squared is equal to 4A squared minus A squared. B is equal to the square root of the difference of 4A squared and A squared, which is 3A squared. Again, A squared is a perfect square, so we can extract it out. Therefore, B is equal to A times the square root of 3, which is also equal to square root of 3 times A. Now, let us identify the length of the legs and the hypotenuse using GeoGebra. First up, we have to create a unit circle. Again, a unit circle is a circle with radius 1. Now, let us draw a 60 degree angle. Okay, so again, you see here that the radii are all 1 unit because this is a unit circle. Now, let us draw a line perpendicular to point C and segment AB. Okay, with the line perpendicular from point C to segment AD, we are able to create right triangle ADC, where angle A is 60 degrees. If angle A is 60 degrees, angle C is 30 degrees. Okay, now we have a 30, 60, 90 right triangle. When the hypotenuse is 1, the length of the shorter leg is 0.5, which is 1/2 of the length of the hypotenuse. The length of the longer leg is said to be square root of 3 times the length of the shorter leg. GeoGebra showed us that the length of the hypotenuse is 1, the length of the shorter leg is 1/2 the hypotenuse, and the length of the longer leg is square root of 3 times the length of the shorter leg. So using our calculator, let us see if the length of D is equal to square root of 3 times the length of A. Now we were able to show using Pythagorean theorem and GeoGebra the relationship between the legs and the hypotenuse of a 30, 60, 90 right triangle. Okay. In a 30, 60, 90 triangle, the hypotenuse is twice as long as the shorter leg, and the longer leg is square root of 3 times as long as the shorter leg. The length of the shorter leg is 1/2 of the hypotenuse. Now, let us move to our examples. Find the values of A and B. This is a representation of the figure from the problem. We see that segment B is parallel to the segment whose length is 12. These two angles are right angles. If this angle is 60 degrees, this angle is 30 degrees. Similarly, this angle also measures 30 degrees because we will be working with the upper triangle first. Let us name the sides as A sub 1 and B sub 1. And we see that from this triangle, the hypotenuse is 12. Using the 30, 60, 90 triangle theorem, we can say that C is equal to twice the length of A. Therefore, when we divide both sides by 2, we can say that A is 1/2 the length of C. If the hypotenuse is 12, the length of the shorter side is equal to 12 divided by 2, which is 6. And the theorem also says that the length of the longer leg is equal to square root of 3 times the length of the shorter leg. Therefore, the length of the longer leg here is square root of 3 times 6, or 6 times square root of 3. So, this is 6 square root of 3, and this is 6. Now, let us solve for the value of A and B, given that the hypotenuse of the smaller triangle is 6 square root of 3. So, C is equal to B sub 1, which is 6 square root of 3. So, from the theorem, we learned that the length of the shorter leg is equal to the hypotenuse divided by 2. Therefore, it's C over 2, or in this case, it is B sub 1 divided by 2. So, A is equal to B sub 1, which is 6 square root of 3 divided by 2. 6 is divisible by 2, therefore we can divide 6 divided by 2, which is 3, then square root of 3. Okay, so the length of the shorter leg is 3 square root of 3. Let us now move to getting the length of the longer leg. The longer leg is equal to square root of 3 times the length of the shorter leg. In this case, our shorter leg is equal to 3 square root of 3. Therefore, we have B is equal to square root of 3 times 3 square root of 3. Okay, let us multiply. So, we have 3 times square root of 3 times square root of 3 is square root of 9, which is 3. Okay, therefore, B is equal to the product of 3 and 3, which is 9. So, for this sample problem, the value of A and B are 3 square root of 3 and 9. From the proof using GeoGebra and the Pythagorean theorem, we can now say that the hypotenuse is twice as long as the shorter leg, and the longer leg is square root of 3 times as long as the shorter leg. That's it for our lesson video for today. On our next video, we will be solving this practice activity. First question. Let triangle ABC be a 45, 45, 90 triangle where angle C is 90 degrees. Find AB if BC equals 8 and AC plus BC is equal to 3 square root of 2 times x. Question number 2. The acute angles of a right triangle are congruent and one of the congruent sides has a length of 12 units. How long is the third side? Next, in triangle M and O, angle M is 60 degrees, angle N is 75 degrees, and MN is 12 degrees. Find its area. And for the last question, consider triangle RST such that angle R is equal to 45 degrees, angle S is 30 degrees, and segment TU is perpendicular to segment RS. If segment TU equals 4 centimeters, determine RT, TS, RU, and RS. I hope you have learned something from this lesson video. Thank you, keep safe, and stay healthy. See you on the next video.